Example 2, the graph of the function y equals f of x is shown, and we want to sketch. So this is very helpful to you to see that there's an f negative 1 there. So f negative 1 will tell you, oh, I need to swap the x and the y first. Just like in the absolute value one, it was something. It could look like, I can use the exact same numbers actually, and it will go like that. And that will tell you, oh, I need to take the absolute value of all my points first and then transform it. This will tell you, okay, I need to swap the x and y's first and then transform it. So I need to, I guess, first find out what my points are. Normally it would just be these, but I got to swap the x and y. So I got to write down what my points are. I think I've got 5 of them here. So I've got negative 4, 4, yeah, negative 2, 0, yeah, 0, 0, 2, negative 2, and 3, comma 2. So I got my 5 points, and I can swap them immediately. So this is my f of x points, but now I'm actually going to find out what my f inverse of x points would be. So I can just swap them, 4 and negative 4, 0 then 2, well 0 then 0, that doesn't need much, negative 2 and 2, and 2 and 3. So I just swapped the x and the y. And now I can apply my rule to all of these points. So let me just take a look at what my rule would be. So for any x and y, now the x, it says times by 2, so I will divide by 2. There's no adding or subtracting. And then the outside stuff, it says times by 2, so I'll do that, 2y plus 1. So I'll do that, plus 1. So those are my transformations. We've been doing a lot of them lately, so hopefully that part kind of makes sense. And so now I can do this to all of my points. So all of my x's need to be just cut in half, it looks like, divided by 2. So 4 divided by 2 is 2, 0 cut in half, still 0, 0 cut in half, still 0, negative 2 cut in half, negative 1, 2 divided by 2, 1. Now the y's are doubled, and then we're going to add 1. So this will be negative 8 plus 1 is negative 7. Doubled is 4 plus 1 is 5. Double 0 is still 0 plus 1 is 1. 2 doubled is 4 plus 1 is 5. And this will become a 6 plus 1, which is 7. So I have these points, and I want to connect them in these exact orders. So I'm going to go 2 comma negative 7. 2, yeah, and then 2, 4, 6, 7. And then 0 comma 5. Wow, way up there? I should double check. Yeah, this can't be 5, can it? Oh, I forgot. See, this is a negative 2. That's a negative 2. So 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. Nice. So this is 0 comma negative 3. Sorry if you caught that mistake and were just waiting for me to find that. 0 comma 1, which is right there. And then negative 1 comma 5 all the way up there. And then 1 comma 7, which is right there. So this thing looks very strange. It's an inverted drawing of our original function, so we had to invert it, and then we did a bunch of things. So I'm going to write down what our transformations were, just because this is the first one that we've done in a while. So this thing is being cut in half, so I would say it's a compression. So it's a compression, a horizontal compression by 2. That's it. Now for the vertical, we're timesing by 2, so that's an expansion. So it's an expansion by 2, and then it's a vertical up 1, up 1. So we're compressing it horizontally by 2, expanding it vertically by 2, and then up by 1. So it doesn't ask for this, but sometimes it's useful to kind of go back and just remind ourselves that there's a bunch of transformations happening. And this is what our drawing in the end looks like. So I'll zoom out in case you need to copy that down, but I will go in here and I'll write down the points. I got 4 points here for letter B. So I've got these points here, negative 6 and 6, negative 2 and negative 6, positive 2 and 6, and then 8 and 6. Okay, so those are our points. And step number 1, it's asking me to do all these transformations to the inverse. So I'll have to do what my inverse is. So 6 and negative 6, I'll swap those. and then swap these, -6 and -2, 6 and 2, 6 and 8. So just swap the x's and y's. And then I can apply the rule or my transformations to these points. So let's see what I have. Okay, well, first of all, I'm going to have to, I can't have that. I need to take out the negative. So take the -1 out, and I'm left with a +2. And to double check, if I bring that -1 in, -1 times x is -x, -1 times 2 is -2. So it does work. Okay, so my rule for my x is I'm timesing by -1. So I'll divide by -1, and then I'm adding 2, so I'll minus it. And then the y's, I'm timesing by -1/2. So I'll do that, and I'm adding 1, so I'll do that. So I can clean this up a little bit. Divided by -1 is the same thing as just calling it -x. Minus 2. And the numerators here are going to be -y over 2 plus 1. So that is our rule. There's a lot going on here. I've got a vertical, for my horizontal things, I got a horizontal flip. And I also have a left 2. I have a vertical flip. And because I'm dividing, I'm compressing. I've got a compression by 2. And I'm going up by 1. So there's 5 transformations happening here. Not that I'm required to write them down, though. I can just plug these points into my rule. So let's do this. Let's do the x's first. So make them negative and subtract 2. So -6 subtract 2 is -8. +6 subtract 2 is 4. This is another 6. I already did that. That's a -8. And this is another 6. Did that. That's a -8. Now for my y's, make it negative, or negate it, sorry. Negate it, and then cut it in half, and add 1. So this will become a +6, cut in half is 3. 3 plus 1 is 4. And then negate that to a 2. 2 over 2 is 1. 1 plus 1 is 2. Negate that to -2. -2 over 2 is -1. -1 plus 1 is 0. And then 8, negate that to be a -8. Cut in half is -4, plus 1 is -3. That's just me doing it in my head. You could just do these. You could just plug the number into here. Like you could just erase this and put in like an 8 and say, okay, that's -4 plus 1 is -3. And you could just keep changing the numbers and whatnot. So it's up to you. So now I'm going to make sure I put these points in correctly and then connect them right away. So -8 and +4 is there, and then over 4 and up 2 is right there. So I have to connect those. And then -8 and 0 is right there. So I'm going back over here. And then -8 and -3 is right there. So that is what our final drawing looks like. We've had a ton of transformations. You have 1, 2, 3, 4, 5 transformations, plus it's the inverse. So there's a lot going on there. I can zoom like that if you need to pause it. And then I can zoom out after that. These are written down in the PDFs. So these are ones where we're given the graph and we have to transform, this time 4 points, transform 3 points. 4 of them. So I've got one transformation for 5 points, another transformation for 4 points. And in the next questions, we'll give you just 1 point, or yeah, we'll be doing 2 points with a transformation. So it's just another way of doing that, where we're only transforming just 1 point. And here we're going to transfer just 1 point. We're transform 1 point. We're not going to do 4 or 5 or 6. And then I don't know if that'll be a whole video. We'll go into doing this algebraically, because it's actually pretty interesting. And there's a bunch of examples there. Some of them can be quite difficult. So anyways, that's the end of that. Let's take a look at example 3 when we get there.